Today, we are lucky enough to invite Astrid, an expert in big meta simulation and software vulnerabilities. Then he is now studying at University College London, which is how to use large language models to detect code vulnerabilities and improve the security of this software. First of all, I want to say, uh, please introduce me. That is, you are in this field now. That is, what's the difference from some previous fields of code security?
The same problem as Brother is that previous code security models tend to use learning-based models, which is to learn vulnerability patterns in the past and then generalize them to the test code. Uh, Now, if we use larger than the model, on the one hand, larger than the model helps us provide a zero-shot environment that can learn the patterns in the code without the help of the training period or with the help of a relatively small number of training machines. In addition, the large meta model can also be migrated to code-related problems because it has relatively strong natural language learning ability because the code itself will also be related to existence. So the main direction of my research is how to enhance these traditional solutions and tools with approximate models or larger than the models. What new challenges does it bring? Then let's solve them. Good.
Can I understand it this way? That is to say, the large language model actually provides more flexibility. That is to say, compared with the previous model, in the process of detecting this code vulnerability, you will directly use an existing, such as an open source or closed element model, and then detect it. Or do you need to do some model fine tuning, use some training data devices to fine tune it, and then use this model to detect that software in the future?
Vulnerabilities are usually fine-tuned because there are a lot of open source models now. It is trained on different code tasks, but there is no simple vulnerability detection task. The vulnerability detection itself has its particularity. Its particularity is mainly that the code may be a very long section, but the vulnerability is only a very short part. So if the O'Hara model is not fine-tuned, it may be difficult to generalize to such a relatively accurate task. So generally speaking, it is still necessary to build some training machines for model micromodeling.
Tune. For example, for a detection of this code vulnerability, I guess it will use some open source code, like some open source code on GitHub, and then mainly these open source codes, or will you also cooperate with some companies to do some avoidable code detection projects?
Well, usually as an academic circle, everyone will use public data and data obtained from public platforms. Or it may require the authorization of the company to cooperate with the company. This is also the limit of the day.
As far as my feelings are concerned, on the enterprise side, they are interested in some tools like AI, a great interest, but on their application side. In fact, there are still relatively few cases and applications that we can see now. In the process of detecting this code vulnerability, which technical links will be difficult in your opinion? For example, if we fine tune a model to detect this software vulnerability, and then, for example, the accuracy is not enough, or will there be some other problems in the process?
I believe there are two main components. Firstly, progress is still insufficient, because today's companies are mainly using the traditional opportunity learning method. For example, I build a training machine, then train a relatively simple ER model, deep learning model, and then detect this model. The biggest problem is when the code vulnerability or malware code changes, it is a new attack invented by a new attacker, or he has made some variants on the old attack. Then, based on the traditional learning model, what they have established is the assumption of independence and identical distribution. Then they will get some newly distributed data and their performance will decline. However, in this case, the company will choose to retrain the model because it doesn't actually bring them much burden. Then continue with the large model solution. First of all, even if we use open source models for fine-tuning, it is still a way that is equivalent to a relatively large training cost. Besides, its results are not said to be very, very good. Well, on the one hand, it may be limited by the imbalance of data and the vulnerability of the code itself, which is a hard part to find, so its accuracy is less than that of a very commercial use. I think there is a second reason. Compared with other tasks such as natural language, there is a very critical point in the current security problem. Explainability is that there are a lot of security experts in the company to explain whether the results given by different models are correct, where the vulnerabilities are really fixed, or or malware, whether it has any new debates, and so on. These things are all analyzed by experts, and this analysis is usually semi-automated. That is, I need to have some domain knowledge and use some automated tools. we do not have a reliable standard to verify the explanation provided by such a large meta model, so if it is further done by human experts, the cost may be higher. I think these 2 points are limited by an automated security analysis tool. 2 questions for the interview.
Now, I'm also doing some independent development and some testing of even an application of AI. And now, like this new open source tool or application is actually, there are endless updates every day. And then you will also feel that there are some security problems which are actually very new, which may not have been encountered before, including a protocol of MCP that has become popular recently. Recently, many security problems have also broken out, such as some that users can't directly see is third-party software, some of which are implanted with malicious code, or you can attack from the large meta-model side. I can also feel that there are some new attack methods now, which we may not have encountered before. In this area, your feeling is like a big meta model, and its generalization ability will be better than before. Those deep learning models will be stronger, right? That is to say, it has some forward looking before.
Yes, but generalization ability and accuracy have always been a trade-off. The more generalized it is, the accuracy of some problems in a certain aspect he sees may decrease. So this is why people use Daiwan tools to fine-tune some specific data sets.
The reason is like some previous deep learning models. Is it based on an architecture of NLP to explain this code? Is it such a logic, or does it grab some feature vectors in some other ways and then do a simulation and judgment?
Well, there are a lot of tools before because the code itself is not just in nature. The sequence structure also has a graph structure, so it is probably divided into several traditional machine learning or deep learning methods to extract some discrete features, such as the names of variables, the APIs used, etc., and then construct a data set and then use it based on. It may employ CNN or MLP, abstracting the code into the representational middle, showing control and data flow extracted by the architecture, transforming it into a graphical structure to learn, followed by NLP integration, regardless of the basis, or the 3 structures of a GNLP. Their essence is to learn the existing patterns in the code and then extend them to the test machine. Then they will definitely pay more attention to training and the patterns that have already appeared in it. When new methods appear, it is difficult for them to migrate. In the past, this was a problem of conceptual drift. Because of this drift, the performance of deployed models would degrade and had to be retrained. If there can be a better way to analyze code based on large meta models, then I think it is a better direction, because he may not have the constraints of training and a lot of training and constraints, but can pay attention to some new models that can be extended to the future.
That is to say, I am using some models, such as machine learning, which are actually applied to some of our daily use cases. We will find that no matter how this model behaves when we train it, when we encounter a new test set, there will be filtering problems, and then its accuracy will drop by 100%, so we are constantly dealing with some new problems. Then I understand, as you said, that is to say, some previous code vulnerability detection algorithms may encounter some shortcomings of machine learning from a macro perspective may be the same, right? I understand correctly. Yes, you just mentioned this graph neural network. Even in AI applications, it also uses graph neural networks.
At present, some people will consider using a multi-modal approach because the code control and data flow are actually difficult to express as a sequence of natural clouds, which is non-sequential. It should be graph structured. So there will be some researchers who will say that I use GNN to learn some feature representations, and then I use the last hidden space of the large model to merge them together, which is essentially a multimodal learning.
For example, like the current agent, because of the agent. Now, for example, even AI users will use it. Different agents undertake different tasks and finally achieve a common goal. Then, like in the process of finding or passing code vulnerabilities, do you think agents will have a significant role, or is it premature to maintain them?
I think using agent to do code analysis is a very promising direction, because doing code analysis itself, if considered from an expert's point of view, is indeed a multi-party collaborative process. I call different tools to do different things and then decide the next decision based on feedback. but at present it is difficult for each major model alone to complete the task of code analysis, which may be limited by the context window. There is no way to cover all the code, or this program is too complicated, and there are many cross-file calls between functions. He has no way to understand so much, so for a single model, analyzing the code is relatively risky, so using the agent method may introduce more problems, but I think this is a future direction, and everyone is also working hard in this direction.
Can I understand this way? If the structure of the software itself is very complicated, and then it has many levels, in fact, the difficulty of detecting vulnerabilities with the big meta model is getting bigger and bigger, right? Yes, in the field you are studying now, in addition to the large language model we just mentioned, directly testing. Like this means reading the context window and directly reading its context and then judging. Then we can use some, such as it is also a direction for the agent to do this detection. Are there any other relatively novel ways? You can find this code vulnerability, which is based on the large meta model.
At present, my research direction is to introduce some traditional program analysis tools into large models, because in the past, when there were no large models, everyone relied on program analysis tools, which may have appeared for 30 or 40 years. Use them to do code analysis, such as slicing code, finding some tainted APIs, and then doing tainted analysis to do data flow analysis, etc. These things are all ways that can provide us with a more accurate code, and it may have potential risks. Then we hope to say that we have no way to further improve our capabilities from the perspective of the O'Hara model, because the capabilities are already very strong. Can I filter the data in the early stage from the perspective of data, and then combine some code analysis tools to help the O'Hara model understand the code? It's not a new tool, but I don't think the tool of history needs to be eliminated completely. If he is completely independent of the model learning itself, he can also be used.
Can it be understood this way? It is somewhat similar to an innovation of a workflow. In fact, the big meta model is added to the workflow. Yes, yes, that is a traditional tool. Can it be understood this way? For example, after it preliminarily parses the code, it can get an intermediate process, and then finally the O'Hara model actually has two ways. It can directly parse the original code text and explain this. This information in the middle layer means that there are actually many variants that can be applied to this big meta model, right?
Yes, but another problem with the big meta model in program analysis is that it usually can only understand the Yuan dynasty, which is the code that humans can understand. However, in program analysis itself, it may have different levels of code. It can be machine code, it can be binary, it can be the intermediate representation of various sense discriminators, but in this case, the big meta model cannot understand it. So this is also what's it called, a gap one by one.
Recently, I am also using the new university model to do some programming. I also found that no matter how powerful its editing ability is, that is to say, no matter how powerful its ability to understand the code is, it will still have a bias, which may also depend on its training data, and if it is more biased towards Python, its understanding of C may be weaker. You can understand it this way: yes, yes, what do you have here? Or, for example, what you are studying now, or yes. Anything else you're interested in sharing?
Is it we are currently doing a work to continue the large model to analyze Android AE software, and then we have a better conference in our field that has been drafted, so we also want to take this opportunity to share this work. For now, for Android software analysis, there is almost no analysis work with big language tools, mainly limited by the fact that Android software is a very complicated application. About the model, just mentioned that it is difficult to understand the complete application, and now it is difficult for the current day one model to support all Android software, because when some Android software functions become complicated, its window can be tens of millions, and it is impossible to be supported by the current day one model, then considering these issues. We feel that it is necessary to help the large model process some data in advance from a data perspective, and then allow the large model to make better decisions. So we first find the more sensitive points in the Android application through program slicing, and then find it through program slicing. It's control and data flow, so we greatly compress the length of code that needs to be input into the large model. At the same time, it can also allow the large model to accurately focus on where potential vulnerabilities may occur. Therefore, in this way, we found that the large meta model can be used to solve the problem of Android OE software analysis, and at the same time, it can also provide a relatively complete explanation. We think this method has not been done yet, but it is a more promising method. We also hope that through the proposal of this work, we can provide you with some ideas for analyzing malware or large-scale programs with the O'Hara model.
Okay, thank you very much. Do you think that if you have some new progress or new research in the future, for example, you are welcome to share with us at any time about the code slicing issue you just mentioned, then how do we do this code slicing? How to achieve it? Is it such a code slice with some fixed rules and then find the most critical code so as to shorten the length of the whole text, or are we using some other methods?
It's not a fixed rule, or it's the program itself. It has some formal languages in itself, so it's also written in a certain form. Our way means that we continue some experiences of our predecessors and gain some sensitive starting points, which are easily manipulated by attackers to achieve malicious behaviors. After that, we transform these programs into control flow and data flow, control flow, data flow. This is achieved through some traditional program analysis tools, and then we use sensitive points as starting points. To find the place that controls it and which data the parameters it calls are controlled by, that is to say, all the instructions related to the current sensitive point in the found program, then if we enter these instructions into the program, it is equivalent to discarding a lot of irrelevant programs. A program that has no impact on sensitive parts can greatly reduce the program length of the input large model.
That is to say, now we use some new methods to detect code vulnerabilities, so we will actually learn from some previous experiences, right? Give him a good combination. Okay, okay, thank you to Estate for sharing so much with us today. To be honest, I am indeed a novice in this area of testing on the road, but after communicating with you, I feel that I have learned a lot. I also feel that this direction will really be solved for everyone in the future. Many questions. It is to improve the security of this code, and then its application scenarios will be very wide. Uh, Thank you very much for joining my podcast today, and you are always welcome to come back in the future. Just share some of your research results or some of your opinions.
Thank you very much for the invitation.
Thank you.